Now that we have a better sense of how our high-level program is going to be translated into machine code, let's go back and figure out how we're going to write the high-level program. We already mentioned that when we want to solve a problem, it is critical to create the right abstractions. One model that helps us into creating abstractions is the object-oriented programming paradigm, and this is the one that we're going to use in this class. On this slide, we're going to introduce a few key terms in object-oriented programming. However, we will be coming across these terms again and again throughout the course and adding more and more details and better understand what they really are and how we use them. So do not be scared of what you will see, because we will be explaining them more and more. A class is a very important term in object-oriented programming. A class is a template. For instance, suppose that we want to model a robot. In programming, we can create a class named robot, and inside that class specify what characteristics we want the robot to have. For instance, the robot may have a name, a color, a maximum speed. We will also specify what kind of operations we want the robot to perform or others to perform on the robot. For instance, the robot might walk or it might speak. The robot might be able to turn right or left, and so forth. All of these characteristics of the robot will be specified inside the robot template or class, as we say in object-oriented programming. Now, after we have written the robot class, we will then use that class to create specific instances of the class. This is what we mean when we say that we create objects of the robot class. So one robot we may have the name Chris, move at a particular speed and be blue. A different robot that we will be creating again from the same robot class may have the name Alan, move much slower and have a purple color, and so forth. Inside the class, we will specify variables. Variables is the way that we model attributes, characteristics, like the color, the name, or the speed. Inside the class, we will also be specifying methods. Methods are modeling operations that objects of that class perform. For example, the speak operation would be a method inside the robot class. The accelerate method might be a method inside the car class, and so forth. When we are writing software, we need to have in mind the basic milestones, the basic steps that are included into the software development lifecycle. First, we need to understand the problem that we want to solve. In assignments in this course, the problems will be, hopefully, well specified. You will have all the information that you need in the problem description. In real life, when, for example, you have a software engineer at a company, the requirements may not be as crystal. It may be that the programmer needs to have multiple discussions with the client of the software in order to specify exactly what is needed. So understanding the problem is, for good reasons, the fundamental step. Then we need to design the solution. Since we are operating under the object-oriented model, that would mean figuring out what classes we need, what objects and how they would interact with each other, what characteristics those classes and those objects would have, and so forth. The third step would be to implement the solution. Go and actually write down the code, the Java code that will be true to the design that we created in step 2. When we are beginner programmers, several times we skip, if not only step 2, also step 1, and we go directly to step 3, sometimes because of great enthusiasm. But remember, before you actually start coding, before you actually start writing Java code, make sure you understand the problem, the requirements, and draft your solution first on a piece of paper. You don't need to write specific long code segments, but you should have a good idea of what classes you will need, how they will interact, what variables you might need inside those classes. A critical step in the life cycle is testing. Especially as beginner programmers, you should have in mind that the time you will need to reach step 3, the time that you will need in order to implement the solution, might be as much as the time that you will need in order to test it. A wise strategy is to write small pieces, small elements of the code, solving small pieces of the bigger problem, test those small pieces, and then move on to writing even more. So in other words, implementation and testing should go hand by hand. We don't want to implement everything to write all of the code and then start testing it. This is almost a recipe for disaster, almost all of the time. So keep in mind that no matter how beautiful you think your code is, no matter how correct you think it is and how you have taken everything into account, most likely you will need to spend a good amount of time in testing. And keep that into your mind when you're estimating the amount of time that you need in order to complete an assignment. It is usually a good estimate to say that you will need as much time in testing as you need in the implementation. Finally, and this is not a step that it is likely to see in this course, the code, the software needs to be maintained. Serious code and code that is successful should stay in a company for a while, should be useful and successful and stay in the company for a while. Therefore, if there need to be updates or patches, someone needs to do them, and the software will need to be updated, maintained, so that it lasts even longer as the requirements and as, for example, the company changes.